All right. So look, the first thing, like I said, you should worry about the domain of this thing. You should worry about the horizontal asymptotes, and you should worry about the vertical asymptotes. The easiest of those, I think, is the vertical asymptotes to kind of look at real quick. So what makes this denominator 0? 1 and -1. It factors, right? X minus 1, X plus 1. Okay, and you can write that out if you want, but I'm hoping at this point that's just like automatic almost for us. Cool. So we're going to have vertical asymptotes at plus minus 1. Now, why that's important is because those numbers are going to be on our first derivative and second derivative number lines. But there's no points there, so they can't be maxes and mins or anything like that. Okay? Okay. So, we got that going on. Secondly, we should worry about the horizontal asymptotes of this thing. Okay, so let's think about this. As x goes to infinity, all right, g of x, let's think, we tell the degree of this thing by looking at, not the degree, the horizontal asymptote by looking at the degree of the numerator and the denominator, right? Which is both, in this case, 1. So what's my horizontal asymptote going to be? 1. The coefficient fraction, right? 1 over 1. Okay with that? However, if we go to negative infinity, and this is something that's kind of unique to square roots in fractions, if we go to negative infinity, it's still going to cancel out to 1, but the numerator is going to be a negative number, while the denominator is a positive number. So the asymptote on the left-hand side is -1. Okay? Okay. Lastly, what else we should look at? Domain. Oh, so domain, the only thing we were looking for, we already did part of it, we found the asymptotes, is if you see a square root or a log, you got to make sure that what's inside of there isn't negative, because there's not going to spit any numbers out. Okay? So we got to take x squared minus 1 and find out what makes it negative. And anytime you want to find out what makes something negative, you make a number line for it. So we're going to make a number line for x squared minus 1. What numbers are going to go on my number line? 1 and -1. Hey. Okay. And you are going to check these intervals, and you're going to get that. Okay. The fact that x squared minus 1 is negative between -1 and 1 means that the square root of x squared minus 1 is going to be imaginary between -1 and 1. And all that means is this graph has nothing on that interval. There's nothing there. Okay? And honestly, without doing any calculus whatsoever, we can graph this thing right now. Okay? And we can answer all the stuff that I'm going to ask you to do. And that's a totally appropriate and fine way to do things. It doesn't work all the time. But just sometimes on the AP test or even in here, I'll give you a function. If you know what it looks like, you just know what it looks like. Okay? You don't know what this looks like? Okay. Look, we got these asymptotes here. And again, maybe this is a lot of work. I know I can do this a lot quicker than a lot of y'all just because I've been doing this for like a million years. But we have an asymptote at 1 on that side. And we have an asymptote at -1 on this side. Cool? All that means is out here the graph has to approach this line. It has to be there. And out here the graph has to approach this line. Okay? We also know we have a vertical asymptote at 1. We remember we found those, right? Boom. And we have a vertical asymptote at -1. We talked about this in pre-calc. I want to switch colors here. I can't get to it because it's dumb recording bars up there. Whatever. We talked about this in pre-calc. When a graph, so our graph is back here, right? When a graph heads towards a vertical asymptote, it either has to shoot straight up or shoot straight down. Okay? And a lot of times you can tell that by looking at what the x-intercepts are. Now, we didn't talk about this for this function. I skipped over it because what's going to make this 0? What's going to make g of x 0? It's not a trick question. Just 0, right? Just 0. However, if you put 0 in there, although the top is 0, the denominator is going to be the square root of -1, which is imaginary, right? So this graph has no x-intercepts. So all that means is when we're graphing it, on the left side here, it has to follow this line. So when it hits that asymptote, it can't go up because there'd be an x-intercept there. It has to go down. Okay? And I know sometimes kids are like, well, how do you know it doesn't do like a weird wiggle or something in there? Just graphs don't do that unless they got weird stuff happening. Okay? These things just follow their asymptotes. So this thing here is going to go this way and it has to go up. So look, right away, we didn't do any calculus yet at all. I'm going to know that this function is decreasing from -infinity to -1, and it's going to be decreasing from 1 to infinity. You can see it on the graph. I also know it's going to be concave down on this interval, and concave up on this interval. I also see there's not going to be any maxes or mins. All right? Now, look, that's a lot of work to do. We haven't done any calculus yet at all, so that might not have paid off, but I can answer every question that I can reasonably ask you guys at this point in time without doing any calculus, okay? And that'll be true with some of these functions. But let's go through the calculus because there's some good algebra going on here too. So we're going to derive x over root x squared minus 1. Let me zoom in here. And I just want to make sure that we can do this math because this is about as bad as it gets for us. We got to do the quotient rule. So g prime of x is 1 times the square root of x squared minus 1 minus x times the derivative of that denominator. And we said the derivative of any square root is always 1 over 2 square root of the same thing times the derivative of the inside, all over the denominator squared. There you go. Are there any questions on that derivative? That's our basic quotient rule happening. There's some chain rule going on, a lot of stuff, but okay. But now we got to find out where we got to find out where this thing is 0 and undefined. And we do that by simplifying these complex fractions. Okay? So first off, these 2's cancel. 2 here and 2 here. They cancel because it's multiplication. There's no plus or minuses happening in there. And we got to get rid of the complex fraction, which means we got to multiply by the square root of x squared minus 1 over the square root of x squared minus 1. And because there's that big old minus in the middle from the quotient rule, which will always be there, we need to distribute this over to here. But what luck? The square root of x squared minus 1 times the square root of x squared minus 1. That's just x squared minus 1. Minus, and look how nice this is, multiplied over to here, it just cancels that thing out. So the only thing we're left with is x squared. All over, we have x squared minus 1 to the first power, really there. And we're multiplying that by x squared minus 1 to the 1/2 power. That's going to give me x squared minus 1 to the 3/2 power. Okay? And that's going to reduce all the way down to negative 1 over x squared minus 1 to the 3/2. All right. So we want to make a number line for that, right? We're going to talk about where it's positive and negative, and we always deal with number lines. So I'm going to write g prime. I'm going to write my number line next to that, so I know I'm testing g prime and not anything else. And I'm going to put the numbers on this number line that make g prime 0 and undefined. To find what makes it 0, you look at the numerator, but the numerator is negative 1. That is never, ever, ever 0. Then you look at the denominator, see where it's undefined, and like we expected, because we already graphed the stupid thing, it's undefined at negative 1 and 1, because there were vertical asymptotes on that graph. So we should have expected that to happen. And then we're going to test the intervals. If I plug in a super negative number, like negative 6 or something, you're going to get negative 1 over the cube, or the square root, see it, of what, 35 squared, or cubed? Whatever. The denominator is positive. Do I see that? If you plug in negative 6 in there, it's a positive number, but the numerator is negative. So that means negative, which means g of x is decreasing on that interval. Okay? If you didn't think about the domain ahead of time, you could pick a number in the middle interval, like 0, and it's going to work out. Like if you check everything, it's going to work out. When you plug 0 in, do you see you get the square root of negative 1 down the bottom there? You get negative 1 to the 3/2. That's imaginary. That lets you know this entire interval, there's nothing in there. And if you plug in a positive number, 5, 6, 10, a million, doesn't matter, you're going to get a negative 1 over a positive thing, which is negative. So this graph is decreasing from negative infinity to negative 1, and decreasing from 1 to infinity, which we thought just from this dumb graph, right? Right. Good talk. Excellent. So then we got to drive it again. Cool. So we're going to find g double prime of x. And I know a lot of y'all want to do fraction or quotient rule here because it's a fraction, but if the top is just a number, I would really just rewrite this dumb thing as x squared minus 1 to the negative 3/2, okay? Because you don't have to do the quotient. You can do the quotient rule. It's a little more work. This is just power rule, really. So when you drive this, you get negative 3/2 times negative 1. That's positive 3/2. Times x squared minus 1. We're going to take 1 away from the exponent. That's going to make it negative 5/2. And we'll multiply that by the derivative of the inside. That's the chain rule. Cool. So that becomes, there's a 2 down here in the denominator of this fraction, but we're also multiplying by 2 over here. Why what? Why is it what?
It was a negative x squared.
Because we're multiplying it by negative 3/2.
Oh.
Okay? So, in this case, those 2's are going to cancel. Goodbye, 2's. And what's down the bottom is going to be that x squared minus 1. Now it's to the 5/2 power, but that doesn't really matter because we just want to know what makes it 0. And up top there is a 3x. Okay? And then we're going to make a number line for this thing. That's simplified all the way down. So I'm going to write g double prime. I'm going to make a number line for it. And what goes on that number line is what makes the denominator 0. Negative 1 and 1. And usually what makes the numerator 0, which will be a 0. But we already know in the domain, 0 is not in the domain. There's nothing between negative 1 and 1. If you didn't know that, you'd probably put a 0 in your number line. You can still test those intervals, but I just see kids mess up a lot of times when they do that. There's nothing in here. So I'm not even going to put 0 on there. 0 is not a viable x value. And then we're going to test these out. If you plug in a big negative number, I don't know, negative 5, you're going to get negative 15 over 24 to the 5/2. That's if you plug in negative 5. That's a negative number, which means the graph is concave down there. Okay? If you plug in a positive number, like positive 5, you're going to get positive 15 over 24 to the 5/2. That's a positive number. That graph is concave up. Okay? And then you list out these. Everybody feel like we can list out these intervals?
Sure.
I didn't write them all out. I'm being lazy. Okay? But really, if we go back into this graph, like all that stuff was there just by thinking about what that graph would have to look like. You can't always do that. Sometimes you're not going to have an idea what that graph looks like. Okay? But we did a lot of stuff last year that hopefully you'll recall in here. But either way, let's stop this.